This lesson is a continuation of the previous lesson. If you look at the directions, it says determine the values of the variable for which the rational expression is defined. In the previous lesson, the direction said this. The direction said find all numbers for which the rational expression is undefined. So here the key word is undefined, and here the keyword is defined. So remember in the previous lesson, we also talked about this. So when we found, for example, in this one, when we found where this rational expression is undefined, we said this: the rational expression is undefined for x equal negative 9 halves and x equal negative 2/3. Then we said this. We said all this means is this, that it means that this rational expression is defined for all real numbers except these two. So when we talk about this set of directions right here, the word defined, we're actually going to use this as our answer. Okay? So watch how simple this is. So so these two directions are related. It's just that here in the previous one, you're looking for where the values of the variable which makes the rational expression undefined. Here you're looking for the values of the variable that makes the rational expression defined. Okay? All right, so number one. So let's look at this. So let's suppose we had this rational expression 8 divided by x minus 9. All right, so you want to know for what values of the variable is this rational expression defined? Well, first of all, think about this though. Think about, well, where is it undefined? Because once you find where it's undefined, then you know where it is defined. Okay, so this is what I just said. This is what I just said. If you know where the expression is undefined, then you know where it is defined. Okay, so here's the way I would approach this. I would approach this using this directions the same way we did these. All right, so what I would do is first of all find out where it's undefined, and that's the previous lesson. Okay, so let's do that. So the question is this: if I want to find out where it's defined, well, let's first find where it's undefined. So this rational expression, remember in our previous lesson, a rational expression is undefined when the denominator is 0. So all you do is find out, well, where is this denominator equal to 0? Well, x minus 9 is equal to 0 when x equal 9. Okay, so then to go back to so what I found is that this rational expression is undefined when x equal 9. So that's where it's undefined. Okay, so it's undefined here, right? So the question is, where is it defined? So then you're going to say this, your answer, you're going to say the rational expression is defined, because that's what you asked about, is defined for all real numbers. So it's undefined when x equals 9 is defined for every other real number. Okay? So all real numbers except x equals 9. All right, and that's it. So if you understood the previous lesson, then you got this. This is easy. Okay, number 2. Let's suppose number 2, we had x plus 7 divided by x. All right, so again, same idea, right? So where's this rational expression undefined? Well, this rational expression is undefined when the denominator is 0. So I said that equals 0, and I already have x by itself. X is 0. Okay, so that's where it's undefined. So this is where it's undefined. So then to answer the question, where is it defined? Here's the answer. You're going to say the rational expression is defined for all real numbers except x equal 0. Okay? Number 3. Number 3, let's suppose we had this. We had 3 divided by 6n minus 42. 3 divided by 6n minus 42. So again, you want to find out where is this rational expression defined. So what values of n, in this case, can I use? Well, let's first find out what makes it undefined. So a rational expression is undefined when the denominator is 0. So you just find out, first of all, where is this denominator equal to 0? So I have this linear equation. So I'm going to add 42 to both sides. And so when I add 42 to both sides, I get 6n equal 42. And to get n by itself, I divide both sides by 6. And so I get n to be 7. So that's where it's undefined. This is the only value for the variable for which this rational expression is undefined, which means that 7 makes my denominator 0. So the answer then would be this. This rational expression is defined. The rational expression is defined for all real numbers except n equal 7. Okay? All right, number 4. Let's suppose in number 4 we had this. We have this rational expression, number 4. All right, number 4. We have x plus 8 divided by x plus 8 divided by x squared minus 16. Okay, x squared minus 16. Okay, so notice again, I want to find out where is this rational expression defined. Okay, so what values of x can I use? Well, let's first find out what values of x cannot I use. So the idea is, where is this rational expression undefined? So remember, the rational expression is undefined. The rational expression undefined is undefined when the denominator is 0. So that means when x squared minus 16 equals 0. And so notice I have this quadratic equation, and so I can factor the left-hand side. That's the difference of two squares, right? So that's going to be x minus 4 times x plus 4. And so notice that when you factor this, the product is 0, so then I can use the zero factor property, because one of those factors must be 0, their product is 0. And so I said each one equal to 0, just like this. And notice that I have two linear equations. So if x minus 4 equals 0, that means x must be 4. If x plus 4 equals 0, then that means x must be negative 4. So those are the two values of x that makes this rational expression undefined. But the question was, what values of x or what values of the variable makes the expression defined? Not undefined, but defined. So you say this, the answer. So the answer, you're going to say the rational expression is defined. The rational expression is defined for all real numbers except x equal 4, comma, negative 4. All right? Okay, number 5. Number 5, let's suppose we have this rational expression, 4x minus 3 divided by 3x squared minus 17x plus 24. So 3x squared minus 17x plus 24. So again, I want to find out for what values of the variable is this rational expression defined. Okay? Well, first of all, let's find out where it's undefined. So I got to take this denominator and set equal to 0, because remember, a rational expression is undefined when the denominator is 0. Doesn't matter what the numerator is. So notice in none of the problems, either in this lesson or the previous lesson, did we set the numerator equal to 0. All right, and notice I have this quadratic equation. It's in standard form. It's in descending order. So all I do is I factor this. And so when I factor this, let's say I'm going to get 3x minus 8 and that's going to be x minus 3, and that should work. So the outer is negative 9x, the inner is a negative 8x. I'm going to add them up, I get negative 17, and a negative 8 times a negative 3 is a positive 24. All right, and so once I factor, I have this product that's 0, so the zero factor property says one of these must be 0. So I get 3x minus 8 equals 0, x minus 3 equals 0. And then I just solve the linear equation. So if 3x minus 8 equals 0, that means that 3x must equal 8. And then that means that if I divide both sides by 3, I get x to be 8/3. Over here, if x minus 3 equals 0, then that means x must be 3. So those are the two values of x for which the rational expression is undefined. So in terms of the directions, where is it defined, you're going to say this. You're going to say the rational expression, meaning this rational expression. So the rational expression, so your answer, you're going to say the rational expression is defined for all real numbers except x equal 8/3, comma 3. All right. Okay, let's look at number 6. Number 6, we have this. We have x divided by x squared plus 9. X divided by x squared plus 9. Okay, so I want to find out where's this rational expression defined. Well, first of all, let's kind of figure out where is it undefined. So this rational expression is undefined. So this is undefined when the denominator is 0. So again, notice just like in a previous lesson, when is x squared plus 9 equals 0? So what value of x, when I square it and add 9 to it, is that going to be 0? Well, remember, that's the sum of two squares. Well, the sum of two squares cannot be factored. And so if I look at that and I get x squared by itself, just to kind of talk about what we're seeing here, look at what you have. If I square x, is that ever going to be negative? And you may say, well, I don't know. Will it? Well, think about it. If x is positive, a positive number times itself is positive, right? So that's never going to be negative. If x is negative, a negative times a negative is also a positive. And if x is 0, 0 squared is not negative. 0 squared, 0. So is x squared ever going to be negative? No. So what that means is that x squared plus 9 is never 0. That's never 0. And so that means that x divided by x squared plus 9 is never undefined. That's what that means. And so what that means in terms of our answer then, you're going to say this. You're going to say the rational expression is defined for all real numbers. And that's it. There's no except. Remember in all the previous the 5 problems we did prior to this, there was always except. There's no except here. You're done. Okay, because remember, I can use any number for x, and that rational expression is defined. It's undefined nowhere. Okay, so that's your answer. All right, and then number 7. So look at number 7, and I think that will take care of our lesson for that. So yeah, that's going to be the last problem. So number 7, we have x plus 12 divided by 8x squared minus 121. I'm sorry, 81x squared. That's 81x squared. 81x squared minus 121. All right, you want to find out for what values of the variable is this rational expression defined? Well, let's first of all find out where it's undefined. So it's undefined when the denominator is 0. So let's kind of figure out where is this denominator equal to 0. Well, notice that this quadratic equation, that's the difference of two squares. I can factor that because that's the difference of two squares. And so when I factor that, when I factor that, I get 9x times 9x is 81x squared. And then 121, that's 11 times 11, right? And so one's positive, one's negative. And so if I check it, the outer's a negative 99x, the inner's a positive 99x, so that's 0. And then 9x times 9x is 81x squared. And then 11 times negative 11 is a negative 121. So this factors as this. And then now I can use the zero factor property. So I set each one of these equal to 0. So 9x plus 11 equals 0. 9x minus 11 equals 0. And so therefore, I solve these linear equations. So if 9x plus 11 equals 0, that means 9x equals negative 11. And then divide both sides by 9, I get x to be negative 11 ninths. Over here, I add 11 to both sides. And so I get 9x equals positive 11. Divide both sides by 9, I get x to be 11 ninths. And so those two real numbers are the two that makes this rational expression undefined. So that's where it's undefined. Okay, so therefore, in terms of where it's defined, is defined for every other real number. So the answer you're going to say the rational expression is defined for all real numbers except x equal negative 11 ninths, comma, 11 ninths. Okay, so the point of this lesson is just another way. Let me go back to it. The directions here is just another way of asking the directions here. Notice though the answers are written differently though. Okay, so the undefined, this is how you can write your answers. Whereas if it says defined, you're going to say the rational expression is defined for all real numbers except where it's undefined. Okay. All right. So that's going to take care of this lesson, where you had to determine the values of x, or the values of the variable for which the rational expression is defined. All right. So that's going to take care of that lesson.